Hello, welcome to this mini session on critical regions for a geometric distribution. We're going to look at an example on how to find the critical region. Charlotte is very good at making cups of tea. She claims she will only make a bad cup of tea every 100 cups. Lucy is sure Charlotte cannot be that good at making tea. Lucy carries out a test. She monitors the quality of every cup of tea that Charlotte makes and counts the number until she makes a bad cup. So using a 5% significance, find the critical region for a one-tailed test of the hypothesis that the proportion of bad cups of tea made is greater than Charlotte claims. And then we're going to find the actual significance level. Let's have a little look at how we might answer this. So we're going to first define the variable. Let the random variable x equal the number of cups until Charlotte makes a bad cup, I believe. Till Charlotte makes a bad cup. We define the hypothesis, so the null hypothesis is the probability is 1 in 100 of making a bad cup. And the alternative hypothesis is she's not that good, so the probability is actually greater than 1 in 100 that she makes a bad cup of tea. So we assume, based on the null hypothesis, that x is geometric and the probability is 1 in 100, or let's just put that as a decimal actually, 0.01, that's a hundredth. So we've got to do a little bit of work in here. So the probability that x is less than or equal to our critical value has to be less than 5%. This is where we start. Just put a line there to show I'm starting the working. So some critical value, there's some number of cups where if Charlotte makes a bad one within that amount so soon, then it's going to be within a critical region. We can say, okay, she's not that good. So let's have a play with this. That's going to be using our formula 1 minus p to the power of c, which is our critical value, is going to be less than 0.05. So that is going to be 1 minus 0.99 to the c. So 1 minus p is 0.99. It's got to be less than 0.05. We rearrange this a bit and I get 0.99c has got to be greater than 0.05. If we move things around, that's what we get. Just some simple manipulation, moving the 0.99c to the right, so it becomes positive, and the 0.05 to the left. And then I've just put 0.99c on the left-hand side. We solve here using logs. So log 0.99 to the c is greater than log 0.05. Bring down the c. Log c times log 0.99 is greater than log 0.05. So I'm left with c is less than, explain that in a second, log 0.05 over log of 0.99. Now log of 0.99 is going to be a negative number. Therefore, when you're dividing or multiplying by a negative number in inequality, we change the sign. So let's just move this up here, running out of room a bit. So C is less than, put this into the calculator, out comes 5.1. That means the critical value has got to be less than 5.1. Critical value is a number of cups of tea made, so it's got to be an integer. So I could say the critical region is less than or equal to 5. So if the first bad cup comes in the first 5 made, then that's sufficient evidence to doubt Charlotte's claim. So that's not really many, is it? Let's have a look at part B, or part 2, sorry. Part 2, so we want the significance level. We're going to find the significance level. So the significance level is actually 1 minus 0.99 to the 5, which gives me, in the calculator, 0.0490. So it's going to be 4.90% to 3 significant figures. 3 significant figures. There we go. So let's just review what we've done. We've looked here to run the hypothesis test, but showing what the random variable is, showing the null hypothesis, showing the alternative hypothesis, that the probability is greater than that. I've done my assumption that x is geometric with a probability of 0.01. And then so we know, well, the probability that x is less than or equal to some critical value has got to be less than 5% or 0.05. And then we solve this inequality. We're very careful about our inequality sign. And we eventually use logs. And we find the critical region is less than or equal to 5. This is really a very standard technique to learn. Part 2, well, you want to find the actual significance level. What's the probability of making a bad cup before the 6th cup? So that there is a bad cup in the first 5. It's 4.9%, which is quite small. And therefore, if there was a bad cup in the first 5, that would be sufficient evidence. Hope that's clear. Thank you very much.